Hello everyone, welcome and thank you for attending today's IBM Middleware User Community webcast. My name is Kelsey Tipshrini and I'll be hosting today's webcast. Our topic for today is microservices, SOA, and APIs, friends or enemies. All phone lines are currently in listen-only mode. There will be a question and answer session towards the end of the presentation. However, you may ask a question at any time during the presentation using the questions window located in the control panel. If you would like to raise your hand, we will be able to get to your questions that way as well. And then you can also look for a forum link in your chat box and feel free to continue any discussions after the webcast in this forum. Tomorrow we'll have the recording and slides of today's presentation available on the IBM Middleware User Community website for you to access. You'll receive a follow-up email with a link to the archives. And now I'd like to introduce our speaker for today. We have joining us Kim Clark. He's an integration architect with IBM. Thank you, Kim, for joining us today. The floor is now yours.
Thank you, Kelsey. Yes, Kim Clark. I'm an integration architect working for IBM. I've been working in the integration space for maybe a couple of decades now. And you'll also notice on the chart Brian Petrini, who co-authored this presentation with me. And we've been listening to customers across the two regions. I work in the UK, he works in the US, over much of that time, and watching them progress through the various sort of levels of integration maturity, as you might call it. And we've seen the way that customers have built up their integration architecture through SOA initiatives, more recently API initiatives, and then the buzzword of microservices comes onto the fore, and there's some confusion about how it's related to things that came before it. Is it really about integration? Is it about applications and so on? So really what this presentation is about, there'll be a little bit of talk about IBM products, of course. We're in that environment, but I'm really going to be talking about the differences between microservices and SOA, where they're complementary and where they're very different. What's really driven this idea of microservices is a sort of fundamental change in the way that IT is being performed. A lot of enterprises have found that they need a greater agility for certain applications. They've got teams that are built up perhaps under a business unit now rather than as a centralized IT function, and those digital teams need to move at a very different pace of innovation. And they need some kind of technology and tooling that's going to be able to enable them to build things much more quickly, prototype, and then scale them out into production much more quickly. And microservices is at least one answer to that question for a particular set of situations. So really that's what's driven microservices, and we'll have a look a little bit later as to why now for microservices. But first of all, I think it's best to start off by making a really clear definition of what we mean by microservices architecture. We'll then compare it to service-oriented architecture, and then we'll look at where things are perhaps going in the future, and then we can have a bit of amusement at the end about looking at what kind of statements start arguments or hopefully stop arguments about the differences between microservices and SOA. So what is microservice architecture? Let's take a step right back, forget about integration for the moment and just talk about microservice architecture. It's really about saying that instead of building applications as a large siloed application in a single application server, perhaps a J2EE application server that has large numbers of Java applications loaded into it, the only way to scale it then is to scale the entire runtime. The only way to change anything is to change it in the same runtime as the other things. So you're ending up with these sort of dangerous dependencies, and it's very difficult to make the kind of rapid changes that you need. We've always tried to build software in broken up, componentized ways. I mean, right back to my beginnings in application development when object orientation came through, and I'm sure you could go back even further. There's always been a desire to break things down into smaller componentry. Microservices is really taking that to the maximum degree and saying we can break them down not just into sets of Java components that are packaged into, say, an EAR file. We can actually break it down into individual network components. So we can have a single runtime, perhaps a single Java runtime or a single Node runtime that is performing a single task and performing that task well with the smallest number of lines of code that we dare put in there. And if we do that, then each of those individual components can be more agile, they can be changed more easily, they can be scaled independently, they can be made resilient in different ways. And I'll talk a bit more about those three key things in a moment. I can see some questions coming in. I'm not going to try to answer those directly on the call now. I'll probably wait until about halfway through and take a look at some of them, and I'll certainly take some time with them at the end, but do keep the questions coming. So agility, scalability, and resilience, those are the key things that we're looking for from microservices. So I'm just going to spend a moment talking about why that might be difficult. So, okay, we've decided to break these components out. It's not just about breaking out the code and the logic, it's also going to be about breaking out the data. Now, anybody who's spent time caring and feeding for a SQL database with hundreds of tables in it for any length of time, adding indexes, changing the normalization of the tables and so on, will know that the idea of breaking that out into smaller components of data is going to be tough. And so we should recognize that to write something in the style of microservices is significantly different to writing a normal application or a siloed application. We're going to have to break that data out. We're going to have to try and find ways to make those components truly separated. Because this is the fundamental thing about microservices architecture, is that the components must be independent. If they're going to be scaled independently, if they're going to be more agile, they need to be independent of one another. If they're sharing data, they're not independent. And so that becomes a really interesting challenge. I think, as I've just seen a couple of questions saying, will this be recorded and where can I get the slides? So this is being recorded, and the recording will be available on this site, and the slides will be available there too. So I'll just cover that one off in case anybody's wondering. The next thing we need to look at then is to say, well, what other benefits does this give us? So we've broken things up into microservices. It actually means that they're completely separate runtimes sitting on the network. So we could potentially use radically different technologies. So we could use different languages for each of the components if it suits them better. We could use Java for computational work. We could use Node for I/O-based work. We could use different databases underneath the microservice components. Some might be SQL databases, some might be object stores or document stores, depending on what we need. There's a lot more flexibility in what we do. We tend to find that people stabilize to a small set of languages that provide radically different capabilities. You don't want to go crazy using every single language under the sun, but you settle down to a few. So back to why microservices. This is my sort of simple test as to, when I'm speaking to a customer, to understand what their motivation really is and whether they're going to get what they think they're going to get from microservices. Scaling, agility, resilience, mentioned them on the slide earlier. By scaling, I mean that they can scale the functions, the services, independently and elastically. So you can, the runtimes are small, they can start very quickly, so you could scale up a single function because it's needed at a particular time, but you don't have to scale up everything together as you would have done with a silo. To do that, you need some fairly sophisticated workload orchestration, and that's why we've seen the rise of popularity of things like Kubernetes and Mesos and so on, that allow us to manage large numbers of containers and virtual machines and so on. Agility, fundamental to microservices, is a small amount of code in each microservice. We can change them more easily. We can version them and get a new version out. We can do subtle testing like A/B testing across a particular component without affecting anything else. So that's really fundamental. But to get that agility right, we've got to get the context right of what individual microservices are. And you'll see us going back to things like domain-driven design from the book from Eric Evans many years ago, to understand bounded contexts and make sure that we break out parts of the data model correctly. And then finally, resilience. Now, you could make a resilient application with a silo, but what we're looking for here is a different kind of resilience. So what we're effectively saying is that the resilience is more focused on the individual functions and being able to provide a sort of separated resilience. We can also use some different kind of patterns as well, like circuit breaker and bulkhead patterns, to make sure that a failure only occurs to one particular part of our overall application, because it only affects those microservices, and even the individual microservices can recover. So it's not that you couldn't be resilient before, it's that you can have a different type of resilience in microservices. Why now? Well, microservices come at a very special time in the progression of IT. There's an enormous number of things, as you can see there on the screen, that have made it possible. Very lightweight runtimes, the rise of DevOps to have smoother movement between development right through to production, capabilities and tooling around continuous integration and deployment, the rise of sort of API-based lightweight mechanisms and protocols, and lightweight messaging like Kafka too. And then into the infrastructure itself, the rise of containers and the ability to use virtualization in much more creative ways with the kind of orchestration we have available today. And we could go on, but I think the key thing is that microservices is possible today because all of these things have converged together, and it's capturing the moment and it's making use of all these new technologies. Just to make it concrete in IBM products briefly, I just want to do an example. This is not a reference architecture. It's not. I'm not saying every microservices environment should go off and use these components, but just to give you the understanding. So WASND is a traditional application server, can contain large numbers of Java applications within it. DB2, a typical relational database. We could move across to a microservices environment. You could use something like IBM Bluemix as a platform to provide you with the lightweight containers to help you manage those containers based on load and so on. You could use Node.js as a component for your business logic. You could use Cloudant or a Mongo database as the background, and of course as the database. And of course WAS has grown and changed dramatically. So WAS Liberty is now available as an exceedingly lightweight runtime that you could use for Java to do things there. So that's what it might look like. And we'll talk a little bit more about how you communicate between these different components. You'll notice I'm mentioning a typical JSON over HTTP API call, but also talking over Message Hub, which is basically IBM's implementation of Kafka within Bluemix. So we'll talk a bit more about that in a moment. In fact, straight away, here we go. So let's just look at how microservices talk to one another. So a microservice, a perfect microservice, would never need to talk to another microservice. It would contain all of its data, be completely independent and decoupled. That's just simply not a reality, though. There's always going to be something you need from somewhere else. How should you make that request or receive that data from other places? Well, you could, APIs seem popular. You could say, well, let's use APIs to make requests to other microservices, and that certainly happens. There's no question that there's plenty of API communication between different microservices. But what we are seeing a rise of is the use of messaging, because messaging is truly decoupled, it's asynchronous, and so having microservices listening to a message hub that's providing an event stream, and being able to dial back and forth in that event stream and build up a data store specific to the microservice is essentially a very brief but basic description of what an event-sourced application is. You listen to the event source and the individual microservices build up what they need. And so they never necessarily have to talk directly to other microservices, they just listen to events. So in any environment you're going to see a mixture of both of those things, but the preference is always going to be events first if you can, and then look at the other types of communication later. So now we're starting to talk about integration. We're starting to lean towards, what does this mean for integration, which is really where my focus is here. You see up in the top right something called service discovery. You could be forgiven for thinking that that's a bit like in SOA we had service registry and repositories. that's not what we're talking about here. A service discovery agent in a microservices environment is more like a DNS server. In fact, in some cases, it's based on DNS. It's really a way for when you do need to do those real-time communications, how do I find the IP address of another microservice? How do I know which of the three that were here 3 minutes ago are still available, and it might have scaled to 10 microservices in that particular function by now? So how do I find them? And a lot of the load balancing is done client-side. So the crawling microservice goes to service discovery and says what's available, what are the IP addresses, and does the balancing itself. So very different to the sort of larger enterprise scale proxying mechanisms and load balancing that you might have had before. So that's a common path in microservices intercommunication. So summarizing then, if you like, there's a boundary to a set of microservices. They're all part of the same application, and they're living in some kind of platform. And that platform is in a way similar to what we had with an application container in the past. Application container provided the generic capabilities. In those days it was more about perhaps transactionality and security and things like that, to the set of applications running in the runtime. In a microservices application, we have a suite of things like service discovery, like the orchestration for scaling or the handling for availability, or the messaging backbones that are part of the microservices framework, and they're part of the platform that the microservices live on. So if you like, we've moved the capabilities, instead of them being part of a container, they're really part of the overall, they're sitting down on the network, and they're sitting down at that level. Okay, when is microservices more of a challenge? So not all systems could be refactored to microservices. It might be very difficult to do that. It might be a system that you wouldn't want to change anyway. It may be more appropriate to break off pieces of a system and gradually strangle it out into individual microservices, but leave some of the pieces behind. Breaking out data stores is going to be a big challenge. If you start with a system and try and break it into smaller data stores, that's going to be, it's not to say it's impossible, but that's going to be one of the key challenges. And you'll need to look at different models, so things like eventual consistency and CQRS are different patterns for handling persistence that you're going to need to use in order to manage the way that you talk to your databases in a microservice environment. So there's a number of things that make microservices more difficult. There's a much longer list of challenges here. I think it's important to recognize that you shouldn't go into microservices lightly. There are those extreme benefits to get in scalability, resilience, and agility. And that's why you'd be targeting microservices. And if you need an extreme change in those three, then that's why you would be doing it. But you need to recognize that you need to have complete automation, for example, test automation, continuous integration, deployment, and so on. You need to think about serialization and latency between those microservices. Have you decoupled them enough to avoid problems with that? And all of the other things on here. I mean, the slides are there for people to look at later, but I think it's important to put across this fact that it is a very different way of writing applications. In fact, Martin Fowler, who did an excellent job of describing microservices in some of the early days, also came back and recognized how microservices, if you like, breaks some of the golden laws it put down at the beginning, like distributed objects. What's the first rule? Don't distribute your objects. What is a microservice application? A set of distributed objects. So, he's got some good discussion there, and there's plenty more out there now, certainly, about how to balance the challenges between distributing your objects or not. Microservices architecture, if you're going to do it properly, you need to go and read quite a lot and get into some new technologies and patterns and things. I think you need to have a good think about how much of this you want to pick off. So are you looking at truly going into writing microservice applications, or are you just attracted by some of the principles? Because at the end of the day, microservices is a collection of good software principles. And so, breaking things down into smaller chunks, handling agility differently, handling resilience differently, and so on. And it may be that you're actually not shifting across to a completely microservices architecture, but you are borrowing some of the principles from there. And I think you need to be clear on which of the two you're doing, because you know, they require a different approach. Okay, so we've talked for quite a while now about what microservices architecture is, but we needed that background for me to be able to then compare it to service-oriented architecture. So let's now dive in and see how that fits together. So one of the most common misconceptions I hear is things like, oh, microservices are APIs, aren't they? And I can see where that's come from. It's come from somebody hearing microservices, knowing about service-oriented architecture and saying, well, service-oriented architecture was, that was about web services, that was about exposing things through a standardized interface over SOAP. So that was about interfaces, and microservice sounds like a small one of those, so maybe it's a more granular interface. Well, what do I know that's a more granular interface than a SOAP web service? Oh, well, these RESTful APIs, they're more granular. So maybe an API is a microservice. Well, unfortunately, it's a very reasonable conclusion to come to, but it's completely wrong. The reality is that the micro in microservice relates to the components, and that's what I've been putting across very clearly in the last 20 minutes or so, is that components are the way that you break up a siloed application into multiple microservice components. The number of interfaces that application makes available might not change. The granularity of those may not change. It's nothing to do with the interfaces. So microservices architecture is really about microservice components. In fact, in many ways it might have been easier if it was called microcomponent architecture, because it would be more clear what it is. It's about the components. It's not about the services that they expose, the service interfaces that they expose. So that gives us a nice lead into comparing it with SOA. So in a very simplistic way, we could look at service-oriented architecture and say it was about exposing things over standardized interfaces across the enterprise. I have all these applications, they've got great data and useful functions, I want to expose them in standardized ways. SOA was trying to do that so that you could then write new applications more quickly on top of those data and function. And so what is microservices in that context? Well, microservices is how I build the applications themselves. So it's really got nothing to do with exposing those interfaces. It's all about how I compose the individual applications. Now this is pretty reasonable because of the approach that I've taken to describing SOA and the deep understanding I've now given you in what a microservice is, but it's unfortunately a little bit naive, and there's a much more expanded description of the difference between SOA and microservices in the article that's in the link on the slide there, but I'm going to try and give you a flavor of why we end up in a lot of arguments and discussions about the differences between the two, because the picture isn't quite as simple as I'm drawing here. So when a large enterprise tackles an SOA program, typically what happens is they've got an enormous number of different back-end systems, lots of different technologies, some of them very deep, quite many decades old potentially. The SOA program turns into really an integration exercise. There's a lot of connectivity happening. How do I connect to that old mainframe system over there? How do I get to that custom application written in a language that barely exists anymore? How do I get to these different systems? And most of the budget, in fact, for the SOA program is spent on trying to integrate and just trying to get through to those back-end systems. And so SOA tends to get its name for just being about connectivity and integration in that environment. Now there's an alternative to that. Take a smaller company perhaps with only a handful of different systems. Perhaps all of those systems are relatively new and they have fairly decent interfaces to them already. So integration is not the big challenge anymore. So that company can now look at the bigger challenge of what SOA was really trying to achieve. SOA was trying to enable you to not just have access to the data in those back-end systems, but to provide it in a way that's more valuable to the business. So to provide, for example, whenever you provide order information, to provide relevant bits of customer information at the same time, or to gather information from multiple different systems together, or to change the data model dramatically so that it's more consistent across the enterprise. There's a whole list of things that you could have been trying to achieve if you look at the deeper methodology of SOA. And if you were doing that and you had less of a connectivity problem, then most of your time would have been spent writing that logic that's just underneath the exposure layer, those service components as they were described in the reference architecture for service-oriented architecture. And if you spent a lot of time doing that, then you were writing service components mostly, which are almost like little small applications that are doing application logic. And if you had the technologies and if you had the lightweight runtimes and those service components started to get smaller and smaller because you wanted them to be more agile and so on, then service-oriented architecture for you is starting to look a lot like microservices. Right? So we've got microservice components, if you like. And so if you've come from a background where SOA was really about that re-landscaping and the changing the way the systems of record looked to make them more reusable, then microservices is just SOA done right, or an evolution of microservice, an evolution of SOA. But if you spent most of your time on the left-hand side of this chart as someone who's focused on integration and how to do integration, then you would see microservices as something completely different, just as a way of writing applications. And so we can see why you can end up with an awful lot of arguments, and it's really arguments over terminology and concepts because people are coming from different backgrounds. So let's take a look at that large-scale enterprise, how it's built up over time. That large-scale enterprise probably had systems of record they've been using for some time. Down the bottom you'll see they might have introduced a hub and spoke integration to get data from one application to another. The dotted lines I've got there are showing that that might have been asynchronous. It could have been files, it could have been MQ messages or something like that. And then a service-oriented architecture program comes along, introduces an enterprise service bus. You'll notice I've put a question mark there because the boundaries of what an enterprise service bus are different for everybody, so we don't want to get into that discussion too much. But nonetheless, what you're ultimately doing is some integration. The thing at the bottom could easily have been IBM Integration Bus, for example, and so might the integration hub above as well. They might even be the same instance. It's just that the one above is doing synchronous requests over SOAP and enabling access to the data that way, whereas the one at the bottom is doing a more asynchronous hub and spoke style of integration. But they could be actually the same instance. And then there's a very clear exposure gateway above that, and that's really what makes the enterprise service bus powerful, because it's exposing the data. And it's interesting how really that's been taken on more by the API function and the API gateways in modern architectures. And so those services are made available on the exposure gateway for systems of engagement, these more rapidly changing applications that we're creating to use. And then ultimately, potentially, we're exposing APIs all the way out into the wider world. So there's the stack of a large enterprise and how it's grown over time. So if we then look at how microservices would fit into that large enterprise, we can see up on the top left there, we've got our engagement application. Some of the new engagement applications, because they're the ones that are changing the most rapidly, are likely to take on microservices architecture, because they want the agility, the scalability, and the resilience. And so we're going to see it as something that's happening in a pocket of the enterprise. But if we look to the opposite extreme, we look on the right-hand side, we could see a greenfield site, a startup, starting with a cloud-native architecture, writing everything in microservices. Large systems of record are often pushed outside because they don't want to rewrite customer relationship management, so they'll get that from Salesforce, for example. And so they use systems of record that are external to the business as SaaS applications. And the microservices are just joining these things together and doing the thing that's unique to the business. So in the greenfield site example, it's the opposite for them. Microservices architecture is fundamental, top and bottom, to their entire architecture. They would even describe microservices architecture perhaps as an enterprise architecture. Whereas on the left-hand side, it's only a small part of the enterprise. It's just something they're doing to write some of the applications in a more agile way. So we've got this controversy as to, is microservices architecture an enterprise architecture or is it an application architecture? And again, it depends on your context, and you can't sort of say one size fits all here. So let's have a look at this, this sort of introduction of microservices into a large organization, because a lot of IBM's customers are in that territory, large organizations with a lot of history. What's happening there? So we've got new systems of record being built in these microservice applications. We're saying that that's a way that we can create things in a more agile fashion. But look at some of this interconnectivity that's changing here. So perhaps some of our newer systems of record are providing APIs. Potentially, the microservices applications don't need to go through an ESB anymore. So that's getting interesting because they could go directly to those systems of record. More interestingly, perhaps, is the question of whether the microservice application should be making any real-time calls to other parts of the organization at all. So that's an interesting question. We can see the dotted line I've got going up to the second set of microservice applications on the right is saying that actually that old hub and spoke pattern is getting popular again, because we would quite like to have a feed of asynchronous events coming up into the microservices environment and allowing them to, in a decoupled and asynchronous way, build up their own data stores. That would be a much more effective and decoupled way. So in a way, some of the old patterns are coming back into fashion again. I think it's also worth noting in this broader picture now the fact that we can see that where real-time interfaces are required, we're seeing that grey bar, the exposure, is a standard thing that everybody wants to use. Whenever I'm exposing real-time APIs and things across the organization, I'm always exposing them in a standardized way. So that's the sort of API management gateway. And we'll come on to the importance of that again in a moment. So I guess this would be a good point to get back to, well, what on earth does this mean in terms of IBM products? Where do they all fit in this overall architecture? So just adding a little bit more depth and concreteness to what we're talking about here. So that evolved integration that's happened on the left, as I said, could have been integration bus. Again, the exposure in SOA style could have been integration bus. If you wanted a more formal exposure gateway, you might have been using API Connect there, which is our API management product. So you could have a combination of API Connect and integration bus to perform those two layers. And then looking at how the microservices themselves are built up, depends the level of depth to the microservices. So API Connect itself, as you can see on the far right, can provide a set of not just the gateway for exposing APIs, either internally or externally, but can also provide the runtimes, Node runtimes, Java runtimes in a collective to enable you to write some code into an implementation of a microservice there, and it can do that in a model-driven way as well. Moving across to the left-hand side microservice application, you could be writing a much richer, full-depth microservice application, in which case you might be using, for example, Bluemix, using WasLiberty runtimes, Mongo databases, Cloud databases, as I mentioned before. And bear in mind, of course, you could still be exposing APIs outside of that environment using API Connect because it's embedded in Bluemix as well. Down the bottom right, you notice this feed of events that I was talking about. It could be feeding events inside a microservices environment. So that could be, for example, listening to IBM MQ. So Message Hub is able to listen to a stream of events on MQ directly, or indeed through IIB if you wanted to filter them and transform them, and placing them directly onto Message Hub, which is our Kafka implementation. IBM Integration Bus also has nodes to talk directly to Kafka databases as well, so to Kafka message queues as well, so it can talk over the Kafka APIs. So just giving you a flavor of the type of products that might be involved in what we're talking about there. Okay, so where might we see Microservices principles used in the future? So at the moment the chart just shows microservices in the engagement layer. Let's just have a look at where else you might use it. It's a set of principles at the end of the day, and so we might take some of those principles and use them elsewhere. So we might build, for example, and you can see the extra blue boxes that I put on, new systems of record might be built using Microservices Architecture. A number of the products being built in IBM today are being built using Microservices Architecture. SaaS products behind the scenes might well be written as microservices. That's kind of an obvious one. A slightly less obvious one is the integration domain itself. So the ESB or the hub doing hub and spoke integration, that could also potentially be broken out into smaller components. Now, do we want to call those microservices or not? And that's kind of almost a religious debate. But the point, the more important point, is that we're borrowing from Microservices Principles. There is no reason why, given how much IBM Integration Bus has changed over the years. It now runs in Docker. It's a very lightweight container. There's all sorts of advances being made to the engine to make it suited to running in a more microservice-like environment. So breaking out what was a thick, heavy enterprise service bus into smaller, more decoupled components that are able to perform integration in an individual form is a perfectly achievable thing. It may or may not be the right thing for your organization, but it's certainly achievable with technology. So I think thinking about that, thinking about how even the gateway itself might be broken into smaller micro gateways as well, there's a lot of discussion to have around how you could get perhaps some of the agility, resilience and scalability of the microservices principles by feeding that into the integration proposition as well. Okay. Now, before I go on to the next section, I'm just going to take a quick check to see what sort of questions have come in and see if there's anything that I can answer quickly here. I think the book I mentioned on the Why Microservices slide was Domain-Driven Design by Eric Evans, and it's a fairly old book but still very relevant. That was one of the questions. The presentation is being recorded and will be available as a PDF download as well. For those who are still asking that question, I think a few people joined later. In mapping to IBM products, there's no mention of App Connect. There was in the second one, so I think perhaps that was referring to the first set of products that I mentioned. And I'm going to come on and talk a little bit more about App Connect as well, so we'll come back to those. Okay, so let's have a look at how this is changing in the future, and I think it's worth. I use this picture a lot with customers because I think it's the way they are viewing their the way they're viewing their landscape now. There's no longer a separation so much between on-premise and off-premise. That's almost become irrelevant. It's more become a matter of what do I own and what do I not have control over. All of the things I own, whether it's on-premise, whether it's in a sort of local cloud, you could call that a local data center, whether it's a dedicated cloud like Bluemix Local, for example, or a public cloud, or whether it's even a SaaS application like Salesforce. If I own a set of data within Salesforce, then it's part of my environment, and I have probably a common security model across the two as near as I can. In terms of single sign-on and things. I own the data that's within my slice of Salesforce, within my public clouds and so on. So really my boundary is that ownership boundary, and integration software we see, I mean I work as part of the offering management team in IBM, helping them to understand where we're headed in the future, make sure that aligns with what clients are trying to do. And speaking to a lot of customers, and this is what we're seeing, that people want to be able to have that integration between different things they own as really a clean platform, be able to get across all of those pieces together, rather than it being just a matter of integrating between on-premise and the cloud, which is too simplistic a way of looking at it. And of course they want to be able to integrate to things that are outside their ownership boundary as well, to business partners, to customers and to other applications as well. But that ownership boundary is more important. Another concept that I think is well worth talking about here is the idea of decentralized integration. I've titled this slide Decentralizing Synchronous Integration because I'm only talking about the synchronous aspects here, so APIs, call between. There is another discussion to have around decentralizing of asynchronous integration, but it's hard to tackle them both at the same time. So let's just take APIs or services internally, potentially, if that's what you're calling them. How might that look in a perfect world? Wouldn't it be great if the owners of systems of record or applications were able to administer and expose their own APIs? Wouldn't it be great if those teams were able to perform their own integration? That's really what we're talking about with decentralized integration. The products have become sophisticated enough, so API Connect is simple enough that a team can just use it. They don't have to get a specialized skill to use it. They can go to it, explain where their APIs are, use the Swagger files to define the APIs, expose them, they'll become available in a portal. Another team can just come to that portal and pick up an understanding of how to use the API, subscribe to it, and then the team that own the API can control it and throttle it and so on. So API management is a perfect example of something that's easily decentralized, and API Connect is embodying that. And we'd like to see that happen across the board for integration. So even for deeper integration, make it simpler for teams to take on, make them able to use more refined capabilities. Now, how does this relate back to microservices? So really the question here is if I'm going to do that, I need to break up the large ESB pattern. Let's remember, of course, that ESB is a pattern, not a component, not a product, it's a pattern. Break up that pattern and say, well, I want to do my integration more locally. I want to be able to do it more locally, but I'd still like to be able to make use of a good integration engine or tools that will enable me to do that. So why wouldn't I take some of my integration capabilities and break them down into smaller pieces in the way we had in the diagram above? So at the moment, I've just broken them down into an integration for each system of record, but we could, of course, go down to the next level again and have smaller integrations still. So we're certainly going to see microservices being used to build applications. So everything that calls itself an application or even a system of record on there potentially could be built using a microservices architecture. But the point I'm trying to get across is that to achieve decentralized integration, to allow teams to fend for themselves, we could potentially do that with the integration layer where it's necessary as well. And API management is already enabling us to do that in many different ways. Okay, something that's just worth briefly returning to is this idea of application boundaries. So I was very careful all the way through to always put a set of microservices within a boundary and say, a group of microservices together makes up what would have originally been potentially a siloed application. And those boundaries are still important. If we're going to break our entire enterprise up into what could be tens, hundreds, even thousands of microservices, we're going to need to be able to group them. And whether that boundary is called an application boundary or a domain boundary or something else, whether that boundary is able to shift more quickly than it would have been able to before microservices is another matter. But we're going to need some boundaries between different sets of microservices. Now, this is important for a number of reasons, but I think, in the same way that we need ownership of an individual microservice, we also need ownership at that boundary level. And we need to, if we're exposing something from one application, let's call it for now, application boundary to another, we expect a different level of governance across those two, a different level of control than we would do within the application boundary. So why is that relevant to what we're talking about today? Well, if we imagine the communication we talked about between different microservice components in the same application, you remember I mentioned that we often do that over techniques like service discovery and client-side load balancing and all of those clever things that are specific to the microservice environment. Even though we might be calling over APIs, the APIs may be making fairly direct requests. When we start to have a lot of microservices, if we put those boundaries in place, it's really clear to see where we need sensible gateways, because we need the gateways between the different applications. One team looking after one application are going to want to make sure that they have some control over the throughput, over the simplicity of how people can make use of the APIs that are available from their application. And so they're going to put up an API management gateway to expose their APIs so that they can be conveniently used by other teams. And so putting those boundaries in makes it nice and clear where we really need the API gateway. We don't need an API gateway necessarily between microservices within the same application, but we may well, in fact almost certainly do, need an API management gateway across different application boundaries. Okay, so I'm going to have another quick look at the questions and just see if there's anything come up. Again, I can answer quickly. Importance of observability for microservices. Yes, so I absolutely agree that that there is a real challenge there. I think this brings up a good point. That microservices is actually relatively immature in comparison to some of the other architectures we're talking about, and so therefore so are many of the tools. And so being able to see your environment of many, many different microservices and how to join those together is really challenging. And we're starting to see a lot more focus on things like centralized logging, for example. So if before I would have been able to go to a single runtime and just look at the logs on there to work out what was going on and diagnose a problem in an application, now that I've got it split up into multiple components, how do I get that same view? And so centralized logging, bringing things together and then pushing them into analytics and dashboards so that we can see a consolidated view across multiple applications is needed. And we've put many of those sort of features into Bluemix, for example. We've got mechanisms for drawing that kind of data together into single analytical dashboards. A lot of the products are now starting to be able to report. So IIB, for example, can report up in a centralized way to collate logs into one place. We're looking at doing that for a lot of other things as well. So those sort of things are becoming really important. And I think the manageability of a microservices environment is a known challenge, and it's one that the vendors are rising to. Comparison. I've got somebody asking about the comparison between SOA versus APIs. So there is a difference. I'll try and state it in a simple sentence, but I'll also refer you back to the first slide, which has a link to an article which goes into this in a lot more depth. The simplistic way of talking about the difference between services and APIs, if indeed there is one, is that services were more focused on within the enterprise and focused on reuse. APIs, in terms of APIs outside the organization, are very much focused on consumability, and so who's going to call that API. So where with SOA we were trying to create a single, for example, get customer method that was usable across the entire enterprise, which is often very difficult to do, by the way. APIs are saying, well, no, I'm going to provide something that's specific to categories of consumers. So it's not. You might have expected my answer between services and APIs to be SOAP or RESTful APIs, and actually that's just a protocol. You could use RESTful APIs to do SOA. You could use SOAP to do APIs if you really wanted to. It wouldn't be ideal. It's not about the protocol. It's more about what you're trying to achieve with the protocol. I think that's as much as I can say for now, but I would refer you to that other article. Do we need ESB patterns in microservices architecture? Depends what you think the ESB pattern was. So if you take the ESB pattern to be just the idea of cleanly exposing services, cleanly exposing things over an API in a standardized way across the enterprise, which is also what you're doing with API gateways and things as well. If that's what you thought an ESB was, then you can still continue to do that even in a federated or decentralized way, and you can call it an ESB if you want. But actually that's not what the industry's come to think an ESB is. Unfortunately, we typically see ESB being the name for an integration engine. It was never meant to be. It was meant to be a pattern. So, you know, if you think that an integration engine is an ESB, then that you're going to get in a lot more of a confusing debate. So I think, you know, there's certainly elements of what the true ESB pattern was that will continue to be present in microservices architecture, but not the way that it's often used in typical conversation. I've got a lot of questions coming in. I'll answer a couple more if I can. Let's just see. Oh yes, I'm being asked to repeat the questions. I'll make sure I do. And is there a framework or reference architecture around how to manage and balance? So I'm assuming that this is talking about microservices architecture itself and how to achieve that. So there are reference architectures for microservices, and I said that in the plural deliberately because there are multiple different views on it, but certainly IBM has a view on microservices architecture. You can, if you search for IBM Architecture Center, then you'll get some of the points of view around that there. And there's a fair bit of microservices literature that we're bringing out, but certainly there's lots of opinions out there and plenty of books on it as well. Okay, so I'll stop with the questions for the moment and just get back to the presentation. So finally then, I see a lot of arguments about SOA and microservices. That's why I wrote this presentation over a year ago or so, and indeed the article relating to it. The key thing is really to try and make sure you're comparing like with like. So if you remember to compare, for example, microservices architecture with service-oriented architecture, or compare the concept of a microservice component with a service component, you might have some kind of reasonable discussion. You're certainly not going to get a reasonable discussion if you say, is a microservice, you know, is microservices the same as SOA, because it's just far too broad a topic. You've also got to make sure that you've got a clear differentiation in your mind between microservices and APIs, and that was what I was talking about earlier. You quite often find that you're at odds with someone because they actually haven't managed to separate what the difference is between microservices and APIs. And just getting that clear often sorts other things out. Unfortunately, I think the word service is so heavily overloaded that it's almost become useless in the same way that objects did in the times of object orientation, and component is pretty nebulous as well. So, you know, comparisons around service, microservice, just as those words, is pretty difficult. You've got to qualify what you mean. So microservices architecture, microservice component, what are you really talking about? So just a few ways, hopefully, to help you to resolve or at least calm down arguments around this kind of territory. I'm going to check if I've got any more questions because I've still got a few minutes left. From the fact that we've had plenty of questions come in, it sounds like this is a pretty dynamic topic for people. I will have more material probably later in the year that will talk in a bit more detail about the specifics of messaging, APIs, where ESBs fit in the future, and comparing that to specific features we're bringing in products as well. But I'll have to wait until after Interconnect where we release a lot of the new information. So Interconnect is our large conference in Vegas that's happening in a couple of weeks' time. Okay, I think we've covered the vast majority of the key questions there. Apologies if I've missed anyone. I've put up on that final slide where you can get to presentations. There is a version of this presentation that's a little bit older up on that slide share, but the ideal place to get this particular presentation will of course be on the site for this webinar. I tend to announce things that I'm working on LinkedIn, so feel free to take a look at what's up there if you want to find more bits and pieces from that. So with that, thank you very much for your time today. Very interested. My email address is on the first page of the presentation. Don't mind people getting in touch. I can't promise I'll be able to get back to everybody, but happy to hear your thoughts and comments on the presentation. And with that, that's me done for today.
Okay, perfect. Thank you, Kim. I'm sorry, I'm just wrapping up a few questions that I see coming in here. Okay, thanks everyone for attending today's webcast. Feel free to continue any discussions in our cloud integration forum. I'll send out that link through the chat right now.
I'm just seeing one question's come in saying, will I be presenting these topics at Interconnect? So yes, the follow-on presentation that I mentioned that goes into a bit more depth about the products and their advances and things like that is what I'll be producing at Interconnect. And I'm very happy to present that in a public forum as well, perhaps this one in the future.
Awesome. And just to follow up, again, we'll have the recording and slides available tomorrow in the webcast archives. You'll receive an email tomorrow with a link to those. And also, as you exit, please take a few moments to fill out our post-event survey. This helps us improve future events, and we truly appreciate your feedback on that. So this concludes today's event. Thank you all, and have a great day.
Thank you, Kelsey.